Hello friends, welcome back to my channel, Power Plant in a Nutshell. Today, I would be discussing about the different components which are used in the boiler. The first of its type is the pulverizer. In this video, I would be covering what do you mean by pulverizer, what are the functions of pulverizer, and in short, I would discuss about the different types of pulverizer which are commonly used in a power plant. Now, let's begin with. Pulverizers are basically a very critical equipment for a power plant. The pulverizers crush the coal, or I would say pulverize the coal into very fine particles of less than 100 micron diameter. Now, this resulted in increasing the surface area to a very large amount. Thus, the coal when enters into a boiler and having such a high surface area to volume ratio, it gets burnt easily and efficiently. Therefore, to have an efficient and as well as the fast combustion of a coal, the coal needs to be pulverized to the very fine particles. This pulverized coal behaves just like a gas. Therefore, its combustion or its properties can be controlled easily and efficiently. The various functions which a pulverizer performs in a boiler are: first is the grinding of a coal, which somewhat I have discussed, that is the main function. Other than that, the pulverizer helps in drying of coal. It helps in segregation of coal particles depending upon the size. And fourth, it helps to transport the coal particles to the boiler. Now, in the following slides, I would discuss one by one the each functions in detail and try to explain the importance of these functions. So, let's begin with the various principles have been are being used in a pulverizer to get the coal to the required size. The first is the impact. In the impact type, the coal is hit with the help of a hammer, and the coal is getting crushed into a very fine particles. In the second principle, that is the crushing, the material is forced between two objects, and this way the coal get crushed or get grounded to the fine particles of the required size. And in the third method, that is the attrition, the coal is grounded or made to the fine size with the help of a with the principle of a friction. In this, the material is basically grounded by rubbing between itself and the wear element or the rolling element, and this way the required size of a coal is used is produced. So now, in a pulverizer, we normally use either one or two or sometimes all three types of a principle to get the coal particle to the required size. So, in the next slide, I will talk about the drying of a coal particle. Normally, an Indian coal contains almost 15 to 20% of a moisture. This moisture has to be removed either in the boiler or in the mill itself. When we remove this moisture in the mill, there are less amount of force or less amount of air is required to carry the coal, because it is easier to carry a lighter particle than a heavier particle. Secondly, if if this moisture is not removed in the mill, then there are chances that these coal particles may get deposited in the pipes and do the blocking or the choking of a coal pipes or pulverized coal pipes, I would say. So normally in a coal there are two types of moistures. One is a inherent moisture and another is a surface moisture. The inherent moisture is basically removed mostly in the boiler itself, but somewhat in the mill, and the surface moisture is basically removed in the mill itself only. Therefore, we when this coal get crushed, the coal is mixed with the hot air, which is coming from the air preheater. Then this hot air uh, dries the coal, and the size of, or I would say the temperature of the coal increases to 75 degrees Celsius. This way, the coal gets dried and its moisture gets converted into a water vapor, and it's flew away into the furnace. Now, the remaining dried coal particle is easier to carry because it has lost some of its weight, and now this dried particle is goes to the boiler with the help of with the help of the air which is coming from the air preheater. Now, this is the whole process of a drawing. I hope you have understood this. Now, let's talk about the other principle, that is the classification of a coal. So, the next important step for pulverizer is to have or is to do a proper sizing of a coal particle. For that, and for ensuring that the coals are crushed to the proper size, we have installed a thing called classifiers. Classifiers are just a vanes arrangement, that veins either open or close or have such a position that they only allow a proper size coal particle to be sent to the furnace. Now, here, what do I mean by a proper size coal particle? When I talk about a proper size coal particle, the coal should not be too fine that it doesn't get the sufficient time for complete combustion. Means as soon as it enters the boiler, it just does not escape away. And when I talk about from the other extremist point of view, that is the very high size, the coal should not be very high, should not be a very high size or a very large size. I would say that it would either fall down, or the time which it has been in the furnace would not be uh, would be sufficient enough to have a complete combustion. Therefore, it is very essential to have a proper size of a coal particle. One more thing which we have noticed it, and which I would be discussing with you in my further presentations, that if you grind the coal too fine, the cost of a pulverizing increases very fast. Means the maintenance cost would be very high, as well as the operating cost would be also very high. Therefore, classification is a very important factor in any mill property. Normally, a general standard is that if I have 1 kg of coal, then almost 99% of the coal should pass through a 5 mesh size, where 5 mesh means that there are 5 square inches of hole in a 1 square inch. Means for a 5 mesh size, the only 1% particle should retain. For 100 mesh size, there should be 90% particles should pass through it, and for 200 mesh size, that is the main criteria, almost 70% of the particles should pass through it. So this will be further discussed in further slides when I will talk about the classification in detail. The circulation of coal. The circulation of coal is required for two reasons. First, to remove the heavy materials such as pyrites and extraneous material. Normally, when I will discuss the internals of a mill in my next slides, you will get to know a thing called scraper chamber. In scraper chamber, the heavy particles of the coal or in the coal falls down and gets collected. Through this chamber only, the air enters into the mill and gets circulated and moves towards the upper part of the mill, that is where the coal is present, and carry the coal. Now, if these heavy materials, or I would say stones, or the materials which cannot be crushed in a mill, does not get removed, then it will fully block the scraper chamber through which the air will enter. Therefore, these materials have to be removed in a periodical way, so that the scraper chamber, or I would say the air will be able to enter into the scraper chamber and then into the mill in a continuous way. This whole system is taken care by the thing called mill eject system or mill eject handling system. So what happens that when we open the scraper chamber door to the atmosphere, the air which is entering into the mill gets also moved towards the door of the scraper chamber and removes all the hard materials, or the all the materials which cannot be crushed, and this way the materials in the scraper chamber gets removed. Once the only air starts coming from the scraper chamber, we fully close the manhole, or we will fully close the door of the scraper chamber, and now the air will move in the upper way. So this is about circulation. One more thing about the circulation is that when I have talked about the classification of a coal, now assume that the coal when get crushed doesn't get crushed to the proper size, means its size is still greater than the 100 micron which is required. Now what will happen if I have to crush that coal? I have to recirculate it. Therefore, the recirculation of the coal has to be done till the time I would get the required size. So, the coal, in order to get the required size, we require classifier as well as we require the recirculation of a coal also. So now I will talk about the in a brief about the different types of mills and the classification based on that. And in the further slides, I would discuss a detailed on the different types of mill as well as the mill internals. There are basically three types of mill: low RPM mill, medium RPM mill, or high RPM mill. When we talk about the low RPM mill, that is the ball and tube mill, in which the dominating principle is attrition. When we talk about the medium RPM mill, that is between 40 to 70 RPM mill, the mills are ball and race mill. In this, the dominating principle is crushing. Normally, it has been observed that the most of the mills used in a power plant are of bowl or ball mill basically. And finally, the very high RPM mill, that is 900 to 1000 RPM, that is the hammer mill, in which the dominating principle for grinding of a coal is the impact. Now, these are the common types of pulverizer which have been used in India. These are ball and tube mill, ball and race mill, bowl mills, XRP for BHEL, then Loche mills, etc. I hope you have liked this video and you have understood somewhat about the mills. In the next few presentations, I would discuss more about mills in detail and their internals and the types of mills, and also about the performance criteria. Till then, good night, and if you like my channel, please press a like button and do subscribe to my channel. Thank you.